Let's find the domain and range of the following functions. We have y equals 3x plus 2. This is a line. We start off with a y-intercept of 2 here, and the slope is 3, or 3 over 1. We go up 3, 1, 2, 3, and 1 to the right. We connect a line through these 2 points, and we can see that the x values, the domain is all real numbers. So x belongs to R, all real numbers, as well as y belongs to all real numbers. So in general, all lines with slopes that are not 0 extend forever in terms of domain as well as range. Now let's sketch f of x equals 5, or y equals 5. Think of this as an airplane, 1, 2, 3, 4, 5 kilometers high. It's a horizontal line that goes sideways with a slope of 0. What is the domain? X, again, belongs to all real numbers. However, the range will say that y equals 5 and only 5. The possible values of y is not above 5, it's not below 5, but it does equal 5. As for the line x equals 3, it's not a horizontal line, it's a vertical line, 1, 2, 3 units to the right. So we say that x equals 3 is the domain, whereas the range will say y belongs to real numbers, because this line takes on every possible y value, positive or negative. We have the line equation f of x equals 2x plus 3. This is like saying y equals 2x plus 3. However, we see that x is greater than or equals to 1. So the domain is x is greater than or equals to 1. Or we can say that x must be 1 all the way towards infinity and beyond. So what's the range? We can sketch this by hand. If we think of the line here, 3 up, 1, 2, 3, and the slope is 2 over 1, that's 1, 2, and 1 right. We connect these points, and we can see that the line extends forever. However, to say that x is greater than or equals to 1, we only shade in this right part here. So we have this point here, and we only focus on the right side. The x value here is 1, and when x equals 1, y equals 2 times 1 plus 3, which is 5. So the range of this ray is y is greater than or equals to 5. We could also say 5, comma, infinity. On Desmos.com, we type in y equals 2x plus 3, and we get a line. However, when we use the curly brace, that's shift square bracket, we type in the domain restriction, x is greater than or equals to 1. And now we have a light ray. And this critical point here is 1, 5. Now let's evaluate f of 2. Recall that f of x equals 2x plus 3, and we'll substitute 2 for x value. So we have 2 times 2 plus 3. 4 plus 3 is 7. That means that when x is 2, the y value is 7 here, and it appears to be correct on Desmos. What we have here is called set notation. These look like alligator brackets, but we want rounded brackets and square brackets called interval notation. When we say that y is less than 3, we're talking about from negative infinity being the lowest possible number all the way to 3 as the highest number. So this rounded bracket means we don't actually include the endpoints. We're less than 3, so we have a soft rounded bracket, rather than a hard square bracket which includes less than or equals to 3. As a number line, y is less than 3. This is 0, -1, -2, -3 is to the left, 1, 2, 3 to the right, and we place a hollow circle here because we're not actually including 3. And we're going to shade in the numbers towards the left. Towards the right we have positive infinity, but to the left we have negative infinity. If this was y is less than or equals to 3, we would shade this point in. However, the fact that we're not including 3, it's a hollow circle, and we shade in towards the left. So this here is a number line, and this here is interval notation. Now let's try this triple statement. Using interval notation, we start at the smallest number, which is 2, all the way to 4. But there's a soft rounded bracket here because we don't actually include the endpoint 4, whereas for the 2, we actually do. As a number line, we go all the way from 2, including the endpoint, all the way to 4. But we leave this hollow because we don't actually include the number 4. By the way, the set notation can also be written as the set of all y such that y is less than 3, comma, oh by the way, y belongs, that looks like a C with a little line going across, to all real numbers. Now this is overkill. The only part we're really interested in is this part here. This here is perhaps the most popular notation.